Welcome back to Generative AI and the Delivery of Legal Services. Today is our review module. Bringing it all together, we're going to be talking about and reviewing modules 1 through 4. First, the context of generative AI in module 1, followed by how does generative AI work, generative AI models and tools, and then finally legal AI tools and use cases. So the nature of this review is going to be fairly high level. I do expect that you'll be reviewing the individual chapters 1, 2, 3, and 4 for further detail, but this is intended as a refresher to kind of re-stimulate those lessons. So the context of generative AI, that was where we gave a backdrop to the historical context of generative AI, first acknowledging that the benefit for lawyers and why you would want to study generative AI as a law student is to learn more about efficiency gains, being able to get more done with less effort, cost reductions, and the ability to empower new service delivery models using generative AI. I always think it's important to understand the before picture. We are all seeing the after picture and the wonderful things that generative AI can do, but the before picture was that we had conditional logic using if-then statements like if this condition happens, then do X. If this other condition happens, then do Y. It works very well, and there's still a lot of applications for which that is an excellent approach. However, if you try to use it for complex or sophisticated applications, it could get unwieldy fast the more and more branching that occurs. And that can lead to a situation like this where you can't keep track and there's an exponential explosion of all of the different options. So this all changed November 30th, 2022 with the ChatGPT moment, and that's when ChatGPT became publicly available and was the first time that I think we were empowered to speak to machines who spoke back to us in an intelligent and fluent manner. So what is generative AI? It is a subset of artificial intelligence designed to generate new content. So that's one big differentiator from prior AI models that could analyze language but couldn't generate language. And now, as we know, it's multimodal, where it could generate text, images, audio, and video. Mindset, incredibly important. I really hope you take away the lesson that it's not a magical oracle. AI is not there to just create the result for us, to create the output. It is not something that we should rely on unskeptically. We need to be critical in terms of what we get from generative AI and review it and bring our human expertise to it before we create it as part of our work product. So the proper mindset is to think of it as a helpful assistant, a co-pilot, or a co-intelligence. The thing about a helpful assistant is that an assistant sometimes gets things wrong. So the mindset of thinking of AI as an assistant will keep us within the context of wanting to review it, make sure that it got it right, and then correct it and add our own expertise to it. We also touched on how quickly AI adoption is happening, and that within 1 year, according to the Clio Legal Trends report, AI adoption went from 19% to 79%, a dramatic jump, but that there is a spectrum of usage that represents, and it's not everyone voraciously using it every day. There is different amounts of usage within that 79%. Walter's Kluwer study, it did talk about using AI at least once a week, so at least we have a greater frequency there, and the percentages speak for themselves. 86% in-house and 76% of law firms are using generative AI at least once a week. Why does this matter? Obviously, we need to take it seriously, and so do you, because you're here studying this class. So how does generative AI work? We spent a considerable amount of time on this because I want you to have more than a superficial understanding of how generative AI works. We talked about artificial intelligence being at a very high level. This is the subject matter. Machine learning is a particular type of approach to teaching machines how to learn that has actually been long-standing. Deep learning is a technique that's applied to machine learning. And deep learning, the deep, as you now know, involves a deep neural network. And that is why it's called deep, because there's many neurons involved that speak to each other and communicate so that you can improve the model. Finally, transformers is a technique within deep learning that allows models to improve by using attention and also backpropagation to improve their interpretation of language and to predict the next word. So within machine learning, there's different types. You have supervised, where there's a human in the loop giving feedback to a computer so that it can improve its score and its efficiency and accuracy. Unsupervised is where there is no human in the loop, and so the model actually uses methods like clustering to determine what concepts and language is related to each other. Then reinforcement learning is where you provide a reward to the system so that it gets a reward when it gets it right, and then it gets punished when it gets it wrong. Is also a helpful way to teach machines. So neural networks, I showed you the relationship. The inspiration behind neural networks is actually based in biology with a neuron, and that we take an input in our neurons from everything that we experience in the world, and that it is processed and then connects to other neurons in our entire nervous system. And actually ties us into the world and allows that feedback to be used to create great behaviors that are adaptive. The perceptron, in a similar way, takes in inputs, applies weights and biases to it that we analogized as dials, that you could dial in a particular setting. Then within the perceptron, there's an activation function that is applied to further enhance the prediction, and it results in an output. So the algorithm, or the recipe by which a model learns, is that it receives the input, makes a prediction, then it checks to see how close that prediction came to the correct outcome, and then it adjusts those weights and biases so that the next time it creates a more accurate prediction. And it looks something like this, where you're taking those inputs, applying the weights and biases, applying the activation function, creating a prediction. Did I get it right? How far off was I? Then sending the incorrect output backwards to calculate or recalculate the weights and biases to further improve the prediction. And so it's this cycle that occurs that's called backpropagation, whereby machine learning models can learn and become more intelligent. They're called large language models for a reason. There's an extremely large amount of data that these models are trained upon. GPT-3, 175 billion parameters, a parameter being a combination of weights and biases, so the dials. So the dials allow for customization and for greater accuracy. The more dials you have, the more reliable and accurate a model you have, the more intelligent a model. So at 175 billion parameters or dials, GPT-3 was somewhat limited, but also a great achievement at the time. GPT-4, by comparison, had 1.76 trillion dials, and for that reason was much more intelligent and able to pass the bar, as we know. Attention is what transformers brought to the game and changed the game by allowing the model to understand forwards, backwards, and then interrelationships between words, and also to ingest it all at the same time so that, like us, it can understand how the placement of words can modify its meaning. And the way it does that is by converting the words as text into numbers that we call vectors. And those vectors establish the relationships between different words and concepts. So it does go beyond just next word prediction. It understands the concept and how that concept fits into a universe of meaning with other words and concepts. And then we use this example to show that if we mapped it to a three-dimensional space, we could see that a word like cow would be in the same space as similar concepts like cowboy or moo. As well, cat would be associated with feline and meow. We also talked about the distinction between general AI and narrow AI. Narrow AI focuses on a particular area of knowledge or skill, like the ability to play chess, to enable voice recognition or image recognition, whereas general AI demonstrates intelligence across all of these different specific areas of knowledge and tasks. In Module 3, we talked about generative AI models and tools. So now that we had a basic understanding of how generative AI works, what are the models and some tools that are used to take advantage of it? And so there's a distinction between open source LLMs and proprietary LLMs. The pros and cons of open source LLMs are that they, on the pro side, are very flexible, community support, they save on costs because we don't have to pay a company for them. We only have to pay for our hardware costs in deploying them. But because we have to involve hardware and deploy them, we do have to have some technical expertise in knowing how to do that. And then there's ongoing maintenance and support because, as we learned, it's not set it and forget it. There's a lot of customization, upkeep, code changes that happen over time that need to be maintained. Otherwise, your deployment could break or it could open up security flaws. Proprietary LLMs, by contrast, are more convenient, accessible. They take care of the ongoing updates. But at the same time, there's less transparency as to actually what's happening under the hood. Those weights and biases are unavailable to us to inspect and see what's going on. And there's potential for vendor lock-in in that the more comfortable you get with a AI vendor, the more information you put into their system, the less likely you're to leave because they already have it. It's more convenient. And there's also limited customization. With the open source, you can really customize it for your data set, even fine-tune a model, whereas you can't easily as do that with a proprietary LLM. There's copilots and there's agents, and we learn the difference. So copilots are synchronous. They require that we sit here, we type in what we want, our prompt, we get a response. We're the human in the loop. It's turn-based, meaning we ask for something, we get something back, but it's fairly immediate in the response that we get. An agent, by contrast, is asynchronous, so we don't have to be tied to each other. We can give it an assignment, essentially, and then it can go out and do that assignment. There are agents that are semi-autonomous. Perhaps they check back in once in a while, like OpenAI's operator does, to see, do you really want to make this reservation? Are you going to have 2 to 3 guests with you? And then you give it some feedback, and it does keep you in the loop to help it and guide it. But there are other agents that work completely autonomously and don't need your intervention. Agents are also adept at planning, so that before they take action, they actually make an outline of the steps that they plan to take, and sometimes seek feedback, like with OpenAI's Deep Research. That is a narrow agent that conducts research. It gives you a plan of action, asks you a series of follow-up questions before it goes out and researches on the web. So an agent minimally requires a large language model that is paired with goals and instructions of what you're asking it to do, with knowledge. So it has to have some facts and information to be able to make informed judgments based on. And some of the judgments it makes is in what tools to use in accomplishing its goal. And tools could be things such as a calculator or the ability to process a payment. Interestingly, it decides on its own, based on the facts it's presented with, if the usage of that tool is appropriate. And so that's something that makes it, empowers it to be able to work semi or completely autonomously. Predictive models. So predictive models, as contrasted with reasoning models, generally have faster inference, so you don't have to wait as long to get the response. They're multimodal and have many integrations, multimodal being different media, audio, video, text. They're more affordable typically, and they result in good enough solutions. So something like GPT-4o or Sonnet 3.5 are typically good enough for most applications. Reasoning models, by contrast, take longer to give the response because they are reasoning, and the reasoning, in fact, is a dialogue where the AI model is essentially talking with itself through the ideas that it has in a chain of thought process. And by doing that, it takes up many more tokens in processing that information, and thereby is more expensive to utilize. But at the same time, it might take more time, but it provides you with a much higher quality result because it's thought through different permutations of your request. And so some models that reflect reasoning are O1, O3, and recently DeepSeek's R1. So some considerations when you use popular AI tools like ChatGPT or Claude or Gemini are its usability. Is it intuitive? Is it easy to use? How does it integrate with other systems? Maybe where you store your files, maybe on Dropbox or Box.com. Does it integrate with that? If you're using Gemini, that already integrates in the Google Apps universe, so that might be extremely useful. Is it cost effective? Well, there's different plans when it comes to ChatGPT. It could be free for limited use. It could be $20 a month, $200 a month, but then if you pay $200 a month, you get unlimited access to larger, more intelligent models. But typically about $20 a month is what you have to pay for access to Perplexity and Claude and a number of other AI tools. Security and privacy, of course, is paramount, especially with what we do as legal professionals. And so you want to make sure to review the terms of service for any public model and ensure that they're not using the data to train on, because remember, the danger with that, the risk, is that whatever information you put in could become public, because when it's trained against, it becomes part of their model, so to speak. And if somebody asks just the right question, it could come up as an answer. So you want to be careful about your privacy settings within OpenAI and any other model. Finally, Module 4, we got to look at legal AI tools and use cases. And there's a distinction between the general purpose platforms we just looked at and legal AI. In particular, there's a difference when it comes to data privacy and security. Most all legal AI vendors know that they will not be in business in the legal industry if they ignore data privacy and security and don't make it a default setting to protect privacy and security. So for that reason, many legal AI vendors have that baked into their systems. And so you don't have to worry about a setting, turning a button off or on to protect yourself. It is just baked into the system. If you use a general purpose platform like ChatGPT, it doesn't have legal specific customization. Yes, it may be able to answer questions about the law, and even give some decent analysis, but it won't match the level of sophistication that a legal AI tool that is trained on legal authority, secondary materials has with respect to the same analysis. There's also limited support and accountability when it comes to general purpose platforms. You can't call somebody up on the phone at OpenAI. With legal AI companies, they understand that support and human support is important to keep in the loop with their customers, lawyers, and make sure everything is working properly, and then if there's any questions, to provide outreach. Finally, integration with existing legal tech solutions is something that legal AI tools enable, so that if you're using Clio as your case management system, it's very likely that other legal AI tools will integrate with Clio or MyCase or other popular legal tech solutions. Some criteria for evaluating legal AI tools would be, again, looking at data security and confidentiality, the domain-specific accuracy. Do they share what documents and what libraries they've trained on? Do they share any, and when I say they, I mean the legal AI vendors, do they share any reports about the accuracy and reliability of their AI in terms of producing answers? Ethical and regulatory compliance. At least legal AI companies are sensitive to that and want to provide a solution that is compliant. And if not, they're going to be in trouble. Explainability and customization. There's greater customization when it comes to legal workflows, so that, as we saw, a tool like AI.law is specifically customized for litigation, can draft discovery responses, help you to draft a complaint, and all of those different applications have questions and settings that are exactly specific to that use case. You don't have to prompt it to get it to do what you want. It's built to purpose. Finally, cost, scalability, and vendor reliability are something that you want to think about in any platform, but specifically with legal AI, the cost can be significantly more than popular tools, and so you want to look into that. So generally, legal use cases for AI are document drafting, summarization, client screening, predictive analytics. How's this motion going to turn out? How might this judge rule? 24/7 legal chatbots that could be on your website to capture new leads. Performing legal research has been a standout. E-discovery in analyzing thousands of documents and extracting information. Finally, contract drafting and analysis is another use case, and there's many more. In your everyday life, you could use it for brainstorming ideas, of course, checking grammar. Emotional support is one that I mentioned where people have used it, and we actually have that within our platform, where you can have a dialogue with the AI about how things are going, and it's actually a pretty good listener. AI is a second mind, or a code intelligence, as Professor Ethan Mollick refers to it, is the idea that you don't use it to replace you. You don't use it to create the output. You don't use it to substitute for your judgment or interaction. You use it to help you think things through, to generate ideas, to stress test your arguments with role play, to visualize complex situations. These are many different ways that you can use AI to actually work with you as a co-intelligence, a helpful assistant to get the job done. So, in sum, we talked about the context of generative AI, its historical placement, and how it came to be. We reviewed how it works at a high level, which is extremely important to understand, because when you understand that, you understand its limitations and what it's good at. We looked at generative AI models, the different kinds, the tools that come from that. And then finally, we looked at legal specific AI tools and use cases. So I'm hoping that with all of that, it's refreshed your memory about everything that we've learned together and has prepared you for your exam. One last thing I'll mention is that you do now have access to the generative AI tutor, which is a chatbot that can answer questions for you about all of this material. And it can also explain different concepts and then test you on those concepts with practice exam questions. So I really hope that you utilize that and that all of this has prepared you for the exam. I wish you good luck, and I'll see you next time.